A car is traveling x feet per second. What does it mean? It means the v is equal with the speed. So x represents the speed. The driver sees a red light ahead and after 1.5 seconds. So t is equal with 1.5 seconds. So this is a reaction distance. So the reaction distance we can write equal. But before I go here, just let me give one of the formula here for the velocity or speed in this case. This is a distance divided by time, but distance is going to be v times t. And now the reaction distance is going to be v times t. But in our case, because v is equal with the x, we can write x times t. But t is 1.5, so d is equal 1.5, so dr, so reaction distance is 1.5x. So this I need now to create one equation in terms of the x to get one of the equations that is here in multiple choice. And after the brake applied, so this is a distance of the stop. So when we are applying the brake, and it says the car takes x over 24 seconds. So here, and this is the same thing, v times t. But in this case here that says, for example, after the brake is applied, the car takes x over 24 seconds. So x over 24 seconds represents 24 seconds represents the time. And now it says during which time the average speed of the car is x over 2. So the speed is x over 2. And if we are applying during the distance, the stopping distance or the distance when we applying the brakes, so ds is going to be equal with the x over 24. So instead of the t, and v is x over 2. X over 2. If we are multiplying these fractions here, is going to be x squared over x times x is x squared over 24 times 2 is 48. So the distance that stops the car is x squared over 48. So let's frame this one. When we need, we are going to take it. And now it says if the car travels 160 feet from the time the driver saw the red light, so this is reaction time, to the time it comes to the complete stop, which of the following equation can be used to find the value x? So the distance from which he saw the red light is the driver's reaction distance, is a plus driver's completing the stop. So those two. And this distance here, we already see the distance here is equal with this distance was 165 feet. 165 feet. So let me write just 165 because we are not using the units here when we find the equation. And now I can apply all of the given information here. Instead of the distance here, I am applying 165 is equal, instead of the distance, reaction distance is 1.5x. 1.5x. And instead of the stopping distance is plus x squared over 48. And everything here now, I am solving this equation. I want to write in the standard form. Everything I'm going to multiply by 48. I'm multiplying here by 48. I'm multiplying here by 48. And I'm multiplying here by 48. When I multiply everything by 48, we can get 48 times 165 is, if we are looking in a calculator, is going to be 7,920 is equal. If we multiply 1.5 times 48, is going to be 72x. And if you multiply 48 with the 48 here simplifies, is a plus x squared. And now I am subtracting both sides by 7,920 and this side by 7,920. This is a cancel, is a 0. So here is going to be 0. And this here is a x squared. And now plus 72x. And is minus 7,920. And if you look in here, which one is the best answer that corresponds with our reasoning is answer D. So D is the right answer.